Good. All right. Good. So I'm going to talk about ixml. I should go, and I'm going to talk about a generalization of it. So I'm guessing that most people know what ixml is, but just for the couple of people in the audience who haven't really seen it before, just to give you the background. So textual documents have an implicit structure that we as humans can recognize, like a date, for instance. But for computers, the structure has to be made explicit to enable processing of the documents. And that's why we've got things like HTML and XML and whatever to add this, the structuring so that the computer can deal with it. So Invisible XML works in a different way by describing the format of the document using a context-free grammar, then parsing the document using that grammar, which gives us an abstract representation of the document, completely void of the input format, in other words, which can then be used in a number of ways, for instance, to serialize to a document with explicit markup. And it's extra information in the grammar that controls the serialization. So the abstract document is the central element, the most important part of the Invisible XML process, since it can be used in lots of different ways. The principal one, of course, is serializing to XML, but there are other possible uses and serializations. For instance, some implementations, at least two of them, serialize the grammar, which is written in ixml but expressed in ixml, into a format more suitable for the parser being used. And some implementations allow the abstract document to be serialized into other formats, such as JSON. Now, we've just had a fabulous presentation over using round tripping, but so in 2024 I wrote the original paper on round tripping that explained that you can actually round trip ixml documents, even though you might have lost some information, because round tripping we just define as creating a new document that would produce the same parse. So that's how we just redefine what round tripping is. And Alain has used that in a very good way to normalize input values, which include grammars. That round tripping works by transforming the grammar that you've got for your document so that it includes the necessary extra characters, such as open bracket, close bracket, added by serialization. And therefore, you recreate an abstract document that would create the same serialization. We do need some extra facilities to be able to do that in a general way, mostly because of attributes which get moved to earlier in the serialization. So then you have to be able to move those back to the right position. So just to give you an example of how round tripping works, here is a ixml grammar for dates, very simple dates. What it does is it takes an input like 071125, and as you can see, it adds the 20 to the 2025. So you would generate an XML that looks like that. So what we do is we take that grammar and we transform it. So what we do is we add all the necessary elements that would come in that serialization. We have to swap some pluses and minuses, because where we've deleted it on the round tripping, we want to add it back. But otherwise, it's a fairly straightforward process of transforming the input grammar into a grammar that represents what we've produced in the serialization. So that then if we take that grammar and then apply it to the serialization, then what we get back is the original string. For technical reasons, it's got one element around it, but that's just detail. Just using the regular ixml processor, so there's no new processor involved here. We've just turned ixml back on itself, as it were, and rewritten the grammar so that it now represents the serialization and can therefore reproduce the original. And I'm sorry, there is a mistake there. That should say 30, just 24. But anyway. it produces the original string. Now, the funny thing is, and a surprise really, is that if you do the transformation twice to the same grammar, then what you get is, in the resulting grammar, is one that both recognizes the original input format and includes the necessary characters to do the serialization without needing to do any XML serialization at all within the ixml processor. So in other words, we get a grammar which does both the recognition and the serialization altogether just by an automatic process. So for the same original input, we produce the same original serialization with some details which are explained in the original paper. So as the round-tripping paper notes, the ixml processor is now unbound from XML, and it could be used to produce other serializations in a fairly straightforward way. So what this talk is about is taking that observation and exploring the design of a generalized version of ixml that allows serialization not only to ixml, but to other structured data formats as well. So the purpose of the design is to parse a textual input, produce an abstract document in just the same way, but now leave all the serialization solely to details in the grammar. So there's no serialization within the processor anymore. So just to take as an example, we're going to take this ixml for a simplified URL. So there's some details that left out of URLs there. But with a simple input like https invisiblexml.org/1.0, we get an XML serialization that looks like this. Now let's assume a version of ixml where the serialization characters are all in the grammar, so there's no XML serialization anymore. So in order to generate this XML form here, we have to add some characters to the grammar. So for instance, a URL, we add the opening and closing tags, and for a scheme, similarly, and in fact, that's all we have to do in this simple case, is just add for each rule, add the opening and closing tags. There's only one difference, is that empty, sorry about this. Empty elements would now turn up as with the opening and the closing tags, and if you want to change that, then you'd have to identify rules that could be empty, and then add that the short version of an empty element into the grammar. Now, if we wanted to make scheme an attribute, we could write it like this. So we've got our opening URL tag, and then scheme goes before the closing broken bracket of the opening tag. And then for scheme, we just generate plus scheme equals and the quotes, and then the content. And so this would then generate URL scheme equals HTTPS. So you can do attributes as well. But now we have more freedom than we have with ixml, because, for instance, we could actually make the scheme the opening and closing elements of the serialization. So instead of saying URL is open brackets URL, we now say URL is open bracket the scheme, whatever that is that we're now parsing, and then the close. So that if we take that same input and put it through this grammar, then we get HTTPS instead of URL as the root tag or the root element. What you'll notice here is that this uses plus on a non-terminal, which was introduced in the round-tripping paper. The plus on a non-terminal means don't parse anything here, but serialize that non-terminal, or output the non-terminal of that name at this position. So in fact, we've used scheme once at the beginning, and that's where we've parsed it. And then at the end there, we haven't parsed it again, but we've reused it and we've output it again. So in other words, we've now got new freedoms. We can generate things that we can't generate with ixml. Now, in ixml, rules combine both the form of go away. In ixml, rules combine both the form of the input and of the serialization all in one place. And because the two are very closely related and the reordering of attributes only happens implicitly, it's actually very easy to see what's input and what's output. It's all in the one place, and it's fairly easy to understand. However, with the new version, the IML version, let's call it, more is required to be included in rules in the new version, and so it quickly becomes hard to read to determine what the input is and what's the serialization. So what I'm proposing now is to do a different form for rules where you separate the input and the output. So here we've got URL, and this it recognizes it as a scheme, a colon, an authority, and a path, and then it outputs it with brackets, the scheme, the authority, the path, brackets, scheme again. And the scheme is just a number of letters. So what you can notice from this is now that all serialization marks which you need in ixml are gone because you put the serialization in a different location. It's now very much easier to see what is input and what's output. It's just obvious there, right in front of you. And what I've said is that if the input and output are identical, as in scheme here, then there's no need to specify a separate output rule. You just leave it without separate parts because they're both the same. So if I now show you the rest, authority is //host, and that gets output as authority host, and so on all the way down. So now we've got, you can see on the left-hand side what the input is, and on the right-hand side what the serialization is going to look like. If a rule should produce no output at all, then you can just supply an empty output path. So as in this case spaces, it recognizes any number of spaces and it outputs nothing at all. It's important to note, though, that each alternative needs an input and an output part. It's not a rule that has a number of alternatives and then an output. No, each alternative has its own output part. In some cases, you can combine it. So, for instance, if you had two versions of a date, for instance, day/month/year or year-month-day, if their outputs are the same, then you can just include your two alternatives in one, as it were, by putting brackets around it and just producing a single output. You need to treat a number of things, or there are a number of things that arise. So, for instance, if you have the same non-terminal being used in a rule, for instance, spaces in this case, this is something similar to an ixml rule. So if you've got name, colon, and then some spaces, and then the values and a full stop, and then some spaces, on the output, you're using S again, and you'd identify it by just stepping through the rule one by one. And so the first S in the output is the first S in the input, and the second S in the output is the second S in the input. And if you end up with more, as in the case of name here, then you just go back to the start again. So in this case of name here, the name just gets output twice. If it's necessary to specify a particular version of the non-terminal in the input, so for instance here, a person is got a first name and a second name, well, then we say a person is a name and a space and another name, which we output as the second name and a comma and the name and the first name. So we just say that a name one is a name and a name two is a name. So you can it's easy to specify particular non-terminals just using regular ruling. So this would take as input, for instance, Stephen Pemberton, and it would turn it into Pemberton, comma, Stephen. So the interesting thing about this is that round tripping now becomes trivial. We don't have to do any rule transformations anymore, because we have both the input form and the output form as separate things. And so if we want to round trip, then we just swap them around the other way. We use the output as the input and the input as the output. So in other words, it becomes much easier than with ixml, because you don't have to transform the rules anymore. It's just all there ready for you, because it describes both the input and the output separately. So just as with ixml, a parse can be ambiguous. And now, because we're designing round tripping into the design, well, that wasn't the case with ixml in the beginning, it will be good to think about how we specify which of the possibilities is the preferred one for the round tripping. So ixml doesn't define which parse to use in the case of ambiguity, so an implementation is just allowed to pick one and output that. But it might be useful, but this does need more implementation work to be sure about it. It would probably be useful to specify that the textually earliest serialization is used on the round tripping. In that way, that you can specify, well, this is what the inputs are, and if you're going to round trip it, then just use the first one of these, so that I always know which is the normalized value, as it were. But as I say, we need some implementation work that needs to be done on that, because we don't specify which parser is used, and this may be difficult for some implementations, but we have to investigate this. It's also worth noting that the ambiguity in ixml is indicated by putting an attribute on the root element of the serialization. And because now we haven't got, we're not producing XML in every case, there's no longer a place to specify that a parse was ambiguous and to include other error informations. So that means that implementations will have to resort to using some other way of indicating ambiguity, for instance by using an error channel, and a bit like how Alain, we just saw with Alain, where he had a whole area where error messages were coming out. So ixml was originally only for structured data, but in fact, now that we've got this method of dealing with input and output, in fact, there are other uses apart from just structured data. For instance, for general editing. So this grammar here takes a number of items separated by semicolons and produces the same items, but this time separated by commas. And that includes, even if the strings that are in that might be an item, if those strings include semicolons, they won't get transformed, because we only transform the ones that separate items and no other semicolon. So you're able to do editing based on structure and not just on textual mapping. For instance, you could reverse a list of words by saying my input is a word followed by more words, and my output are the words that I matched in the first half, followed by the word. So then we get the reversed list. And in fact, IML could be used for many similar cases to how sed and grep are now used, except that now you're able to select on structure as well as text. So in other words, it would be much, much more powerful. So in my original 2013 ixml paper, I pointed out that something like this, open curly bracket, A colon 1, B colon 2, can't be transformed with ixml into elements with A with the content of 1 and element B with the content 2. But now with IML, that is possible, because as we saw with using input as the names of elements, we can just do that here. When we match a member, which has got a name and a number, well, then we just output the name as the name of the element and the number as the content of that element. Now, IML actually makes the implementation of ixml much easier, because now all we need for ixml is grammar transformation. So we transform an ixml grammar into an IML grammar in the same way that ixml round-tripping did that. But now we've made the ixml implementation that much easier because it doesn't have to know anything about XML. It can just get all the information from the grammars. The only special case you have to deal with in transforming an ixml grammar into an IML grammar is that you have to deal with XML special characters such as open and broken bracket when that appears in text. So, for instance, if you've got a grammar that said a line is just some number of characters followed by a new line, well, we need to transform that into a line. A tag line, and then those characters, and then the slash line, which ought to have quotes around it. But the definition of a character, we have to include the fact that the open broken bracket has to be transformed into ampersand LT semicolon. But those are small details, and it makes ixml just an application of IML through transformation of grammars. So this is a proposal that I've been working on. It's not yet complete. In particular, ixml allows nodes to be moved from very deep in the parse right to the top. And so you might have to have something like this that says where you get your values for your top level nodes. So my conclusion is this is not yet implemented. It's only a proposal, but it looks like it would be an exciting generalization of ixml, allowing many more use cases, but also making ixml simpler in itself. Advert. The first International ixml Symposium is going to February 26th and 27th. It's be only online. It will be free to attend. The presentation deadline is December the 15th. You don't have to do papers, just an abstract. So if you use ixml, if you have ideas for ixml, anything, we want to hear about it. You can talk from 10 minutes to 30 minutes. You can say yourself how long you want to talk. So please send in presentations. Thank you.
Questions, anyway? Hans Dieter.
Thanks for the talk. I was wondering, basically two questions. You're in IML restricting yourself to context-free grammars in that structure.
Again.
So yeah. there's not things such as tree sharing. Say you want to parse an opening tag of XML and you want to make sure that the closing tag has the same value. That's like sharing a node.
That's right. It's still context-free. That's right.
It's still context-free.
Yeah.
Would it make sense to go beyond context-free? For instance, like tree-adjoint grammars, or the computational linguistics have done a lot of work the past 20 years or so. So yeah. There's richness, such as, well, many different kinds of grammar formalisms that go beyond context-free, which do allow you to parse XML as well. Would that make sense to push IML in that direction?
Definitely, it would be worth investigating. Please submit something to the workshop.
Mohammed.
Just a remark, not a question. Why not IGML? Because it looks to me a lot like the concrete syntax of SGML.
Sure.
Should we rename the function in Qt4.
Well, ixml really only does produce XML, and that's fine. I mean, there is a distinct use case for ixml. This doesn't replace that. This just extends it to other formats.
Norm, if you want to say something publicly, you can unmute yourself, maybe.
Well, I mean, I was happy enough to just have it in the chat. That's very, very interesting, Stephen. I'll have to think about that. I'm not at all persuaded at the moment, but there's certainly some interesting ideas there.
A bit of mine with Norm on this, but Stephen, one of the things I've found is that the XML part of the handling all the ixml is the easy bit. It actually, removing the XML actually wouldn't save a great deal of implementation problems. Most of the problems that I've found has been in both in the parse, but particularly in the generation of the appropriate result trees, which you still have to deal with because it's part of your processing, post-processing of your the result of your parse. Thank you.
Yeah, no, I agree. It doesn't make it very, very much simpler, but it was more to show that it would be possible to use IML to implement ixml without too much difficulty.
Yeah, I understand that, and it's interesting to try it out and see what happens. Thank you.
Yeah, okay.
A last question from anybody on Zoom? I guess not. Thank you very much,
All right.
Stephen Pemberton.